So when we see a table, the starting point is always to find change in y's and change in x's, because it's that rate of change that'll give us an idea to what the function is. So on this first warm-up table, the two change in y's that we can find are both plus 10. Okay, and 10 divided by 1, that is constant. That's the same for both of those. Okay, so now that's that unit rate, right? For 1x, we're changing 10 y's. All of our x's are going up by 10. So the one thing that we know for sure, as we work down in this table, we will add 10, and add 10. Okay, and that can help us fill in all the missing spaces. 24 plus 10, 34. 34 plus 10, 44. And 44 plus 10, 54. Then remember, if we go the opposite direction of where our arrows are indicating, we do the opposite operation. So instead of 14 plus 10, I'll do 14 minus 10, making that missing space 4. Because this rate of change is constant, and constant without the plus or minus, that means this is a linear table. All right, and then for that third one, I noticed that I go minus 1, minus 1, minus 1, but then eventually I'd get back to negative 21. That's some indication of symmetry, right? The two negative 21s are that indication of symmetry. So at some point, we need to switch from subtracting to then add. Okay, so I'm going to first just see if I subtract 1 more time, is that going to help me get to negative 21 eventually? Well, it will if now I start to switch from minus 1 to plus 1. So negative 23, negative 22, and then that ends with our last value there at negative 21. That makes this table absolute value because it's constant, but constant where we're adding and subtracting. Okay. So now let's jump into our newer tables today where we're going to introduce the quadratic function, the quadratic tables. And when I see all these tables, I'm going to always approach them the exact same way. Okay, so when we see a table, we're going to always start with finding change in y and change in x. Okay, and we'll pretend, even though I've already kind of told us this is quadratic, we'll pretend that we don't know that right away. Okay, and we'll see if we can't figure it out with the rate of change. So every time we see a table, we'll always fill in our arrows. If it's all plus 1, we can just write that once. Okay, but then with the y's, we need to find each one here. So 8 to 5 is minus 3. 5 to 4 is minus 1. 4 to 5 is plus 1. 5 to 8 is plus 3. 8 to 13 is plus 5. And 13 to 20 is plus 7. And the last one, plus 9. All right, so after we find all of our change in y's and change in x's, and thus the rate of change, we want to ask ourselves, is it constant or non-constant? Definitely non-constant here, right, because they're always different. Because it is non-constant, and because there is some symmetry, right, I see this 8 twice, the 5 twice, and then this negative 1, 4 must be the turning point, because that's where the symmetry kind of aligns after that and before that. That means that this is a quadratic table or a quadratic function. So here's the part that's new, and it's this next part that's going to help us fill in the missing spaces when we get to those types of tables. We now need to find what I'm going to call the second change in y. Okay, and we're only doing this if it's a quadratic table. Okay, so again, it was quadratic because of the non-constant and the symmetry. And then the second change in y, if it is quadratic, should be constant. So from negative 3 to negative 1, add 2. Negative 1 to 1, add 2. 1 to 3, add 2. And sure enough, all of these are adding 2. So that's another feature of a quadratic table, and that the second change in y should always be the same value. And the way that we're going to describe the rate of change is we'll say it is increasing because we're adding in that second change in y. and it's increasing by 2. So a couple things that I've noticed with some of the other classes and students that are picking this up well. What they're doing is they're being very intentional with the arrows, and they're also being very intentional with whether or not we're adding or subtracting. Okay, it might seem small, it might seem minor, but makes a really big difference. So I still want to see the arrows, and we're going to always draw our arrows as we work our way down in the table. I really want to know, are you adding or subtracting? Doing those two things are really good habits as we work through these tables. Okay, so make sure we continue to do that. All right, let's do number 2 as well. And then the next 2 we'll have you do in your groups. And so again, I'm going to always start the same way, pretending I have no idea what function it is. And change an x. All the change in x's are all plus 1. Still drawing the arrows. The y's here, negative 44 to negative 26, maybe that's one that we might need a calculator for. And if that's the case, that's absolutely okay. Okay, with the note sheet that we wrote today, remember to find a change in y. I can take one y value and subtract it from the one that comes before it. So negative 26 minus negative 44 is plus 18. The next change in y, negative 26 to negative 12, is plus 14, and then plus 10, and then plus 6, and then plus 2. But then we switch, and now we're going to minus 2, and then minus 6, and then minus 10. So again, notice how I'm writing the arrow for what I'm doing as I work my way down through the table. And I'm being very intentional with whether I'm adding or subtracting. Okay, so what do we notice? The rate of change is not constant, right? There should be some indication of symmetry. So do I see some values that show up twice, like negative 12 and negative 2 and 4? And that helps us identify what the turning point would be, which is at 2, 6. So these things help us decide that this is a quadratic table or a quadratic function. And the rate of change we describe using the second change in y. So the second change in y, 18 to 14 minus 4. 14 to 10 minus 4. 10 to 6 minus 4. Minus 4. Minus 4. Minus 4. One sec, Giannis. Then the rate of change, we'll say, is decreasing. And is decreasing. You could either say decreasing by 4. If you want to say by negative 4 and indicate the operation, that's okay too. Okay, someone's like, well, isn't that actually making it a positive? Yeah, right. If we're minusing a negative 4, we're adding. But again, I'm looking more for, do we recognize it increasing or decreasing? And then by what amount? Okay. So for number 3, you should have found that the rate of change goes from positive 4 and then switches to negative 4. That's the constant rate of change where we add and subtract, making it an absolute value table. The rate of change we would just simply describe as being plus or minus 4. Okay, so constant, but plus or minus. Then number 4, one thing I'm noticing, even just the y values, not even necessarily in the change in y's, but the y's are increasing really, really fast. That kind of gives me an idea that this is an exponential table right away. Okay, but then if I find the change in y's, I'm seeing that same thing, that they're increasing really quickly. So all those change in y's, I notice that we go from 1 to the next by multiplying by 3. Now, one thing that we took a note of, okay, right at the beginning of class, is how to find that factor. If you're sitting here like, Mr. Younger, how did you know that it was times 3? Well, I can take one change in y, like 54, divided by the one that comes before it, and that 3 is that factor. Okay, so that means we're taking one change in y, multiplying it by 3 to get to the next one. And we would say that the rate of change increases by a factor of 3. Okay, we got one more table together, and then you're going to do number 6 in your groups, and that's actually how you're going to get your homework today. You have to complete number 6 and get it correct in your whole entire group. So, here we go, number 5. Again, I'm going to pretend like I have no idea what type of function. If you're finished, then really think about the language and how I'm approaching how I fill in this table. Okay, because maybe you have different ideas. So still be a part of the conversation here. Okay, always start with change in y's and change in x's. All of these change in x's are plus 1. Now you're going to have to wait. The change in y's go from 1 to 8, so plus 7. 8 to 13 plus 5. 13 to 16 plus 3. 16 to 17 plus 1. And 17 to 16, now we're subtracting 1. Okay, so after we find all of the rates of change, questions we ask ourselves, is it constant or non-constant? This is definitely not constant, right? They're always different. Then I'm also wondering if there's any sort of symmetry. There's a little bit here, right? 16 and 16. In between those 16s is that turning point, which is also where we switch from adding to subtracting. Okay, so those, the non-constant rate of change, the symmetry, and the fact that we're adding and subtracting means that this is a quadratic table. So now, this is the part that I think is really important that a lot of students are kind of missing here. When we need to fill in the missing spaces, we have to focus on what do we know for sure is going to be true for the entire table. And that's that the second change in y is constant. So the second change in y here, from 7 to 5, I'm minus 2. 5 to 3, minus 2. 3 to 1, minus 2. And all of these are minus 2. So what I'm going to do to fill in the rest of this table, I'm going to start with all my second change in y's, where they're always subtracting 2. Using the second change in y's, I can now find the first change in y's, where I can do negative 1 minus 2, which is minus 3. Minus 3 minus 2, which is minus 5. And minus 5 minus 2, which is minus 7. Once I find all the change in y's, now I can just fill in what the remaining change in y's are. So 16 minus 3 is 13. 13 minus 5 is 8. 8 minus 7 is 1. Could also just use the idea of the symmetry, right? If we know that it's quadratic and that it has symmetry, we can figure out it. Okay, so now, rate of change, we would just say decreases by 2. All right. Last table, number 6. Your task